is Nana Hutchinson, representing Group 9, and I will be demonstrating the integrated circuit technology behind our project. We are building a self-preserving plant vivarium which can regulate soil moisture, temperature, and a day-night cycle for lighting. These self-regulating systems will be powered by Arduino Nano microcontrollers, supported by sensors and power relays. The first Arduino Nano setup I will be demonstrating is the day-night cycle. Looking at my C++ code for the Arduino, I've set my relay pin to data line 2, which you can see in this configuration here. It is tied to 2 for my in signal, and the ground is tied to ground on the Arduino Nano, and the VCC is tied to the 5 volts pin. Looking at my C++ code, the relay pin is 2. As demonstrated, the pin mode is relay pin output, which will be demonstrated later. The loop for this code is power on relay. This delays for 7,000 milliseconds or 7 seconds, and then powers off the relay and delays it for another 7,000 milliseconds or 7 seconds, and this loops. The power on relay calls for this recursion where the relay pin is wrote to high and the serial monitor outputs relay on. And when the power off recursion is called, it does the opposite and writes the relay pin to low and prints relay off. Now looking at the serial monitor, you can see if I clear the output, it's just going to turn on and off the relay every 7 seconds. And for the day-night cycle, I will increase the values to make this only for 8 hours on, and the rest of the day this will be off, and this will just repeat. And if I flick on the switch, which is connected to the outlet, which I've capped off and spliced and connected to the inputs to the relay in the normally open configuration. Observing the light over here, this will just switch on and off every 7 seconds as demonstrated. For the day and night cycle, this Sunblaster grow light will be used in order to promote healthier and faster growth for the plants. So this is the second Arduino Nano setup, which is a bit more complicated than the previous, as I have an integrated sensor right here, which is the TMP36, connected to my Arduino Nano here. And looking at my Arduino Nano code in C++, here I have my sensor pin, which is analog 5, and you can see over here A5 is connected right here to my sensor through the green line, and my relay pin is going to be the same data line 2 on this left side here. And I have some float values. I have my high temperature and my low temperature. So at 83 degrees Fahrenheit, this cuts off the relay, and at 79 degrees, this does cut on the relay. And these are just close to room temperature values for demonstration, which will be changed when we implement the actual plants into the vivarium. But this float V reference will be explained later. That's the voltage reference signal. And for the setup, I have the same relay pin and output. And in my loop, I have sensor value, a float sensor value, get temp, which calls to receive the value in Fahrenheit. And the get temp comes from over here. I have my integer sensor value, which comes from analog read sensor pin. So that reads the A5 and gets the analog read from the sensor over here. And I convert this to millivolts, which is just taking the sensor value and dividing it by 1023 and multiplying it by the V reference, the voltage reference, and multiplying it by another 1000. I will explain this V reference later. Converting the millivolts into degrees Celsius, I take the millivolts minus 500 and divide that value by 10, and just doing a basic Celsius to Fahrenheit conversion here, multiply by 9/5 and add 32. And this just prints the degrees in Fahrenheit to the serial monitor and returns the degree Fahrenheit value as the get temperature. So in my logic here, I have an if statement. If the sensor value is greater than or equal to high temp, this powers on the relay, and this basically cuts off the light. And this V reference here is equal to 4.697 volts, which is the voltage that is given by the 5-volt VCC when the relay is on, and when the sensor value is less than or equal to the low temperature, which is 79 degrees, this powers off the relay, and the V reference is equal to 4.574 volts when the relay is off. And I did realize this. I got these measurements from the multimeter when I did actually do the more accurate reading on the actual voltage from the 5 volts pin over here. So because this is a temperature that's dependent on the millivolts, I have to be able to have a very accurate reading of the voltage in order to have an accurate temperature. So I just delay this loop for 1000 milliseconds or 1 second. So this should be 1 second. So every 1 second, this either powers on or powers off the relay based on the temperature that's received from this sensor. Of course, I will not be using this light bulb for this setup. I'll be using these ceramic lights, which do output heat, but because you can't see when this is turning on and off, I'll just be using the light bulb for the demonstration. And I will look at the serial monitor, and you can see that this is at 75 degrees, so the relay will be off. And flicking on the switch, because the relay is off and the temperature is too low, this will cut on the heating lamp. And if I actually squeeze this temperature monitor, I can use my body heat to raise the temperature, and you can see it raises up and it hits 83 and the relay turns on. The light is now off. And if I release it, the heating lamp won't turn on until this reaches 79, which is my low temperature. So we can wait and see when this temperature finally drops back down. This may take a little while. So having the light bulb right here, once it reaches below, you can see the light bulb did cut back on. And that will be the heating lamp in the real application, but this is just for demonstration. For my last demonstration, I'll be showing the Arduino Nano, which controls the soil watering system. And here I have my capacitive soil moisture sensor and my fresh water pump. And this is a 12 volt 3 amp pump. So I have the 12 volt 3 amp power supply here, which I have now connected to the relay. And for my C++ code connected to the Arduino, I have my constant integer dry. And when I do my analog read for the sensor, 622 is the highest dry level, which I did get, and the lowest wet level I got was 320. Now, using the same integer relay pin as data line 2, I now have a constant integer off level of 50. So this basically cuts off the soil moisture relay when the soil moisture level is at 50%. Here goes my pin mode relay output, which sets my output to the relay pin of 2. And looking at my loop, I have my soil sensor value, which analog reads A0, and you can see A0 that is connected to the capacitive soil moisture sensor. And this just gets the value, which can be somewhere between these levels of 622 and 320. And I have another integer, moisture level, which basically just takes these values of sensor value and converts it to a percentage level. So here I have this prints out the moisture level to the serial monitor, which allows me to observe the moisture level. And going to my if statements, I have if the moisture level is greater than or equal to the off level, which is 50%, I power on the relay. And when else condition, basically meaning when it's 49 or lower, this cuts off the relay. And I do this check, which runs this loop every 1,000 milliseconds or every 1 second. And before I did have 10 seconds, but now I'm doing 1, so I'll just change this to 1. And these are just my calls to power on and off the relay. And I'll plug this up and show how this works. Here you can see that the soil moisture level is 0% because the sensor is outside of the water. The motor is on. Now I'm going to dip my sensor into the water, and this cuts off the motor. And if I take it off, actually if I look at the monitor here, you can see it says 77, 76. And if I take it back out, this cuts the motor back on. And you can actually see when I take it out that the temperature or the moisture level will drop. And that's a relay off. In conclusion, the dimensions of the enclosure and placements of the components will have to be finalized, and the decision of plant choice will determine the calibration of the sensors on the Arduino. When finished, plants in the vivarium should be able to thrive with minimum human interaction, where the maintenance will compose mainly of replenishing water and supplying fertilizer every couple of months. The final product can serve as a great aesthetic, an organic vegetable farm, or a great tool for a hobby, as the variables can be configured to support a variety of specific environmental conditions for several plant ecosystems. That's all for now. Thank you for watching.